All right, guys, this is your tutorial for today, Thursday, October 8th. Please make sure that you have clicked the attendance link down at the bottom and signed in so that we can give you credit for watching this tutorial today. We are going to be taking notes on heat and wind, so make sure you click in that classwork tab of Google Classroom and you get your template out so that you can take notes as I go over the presentation. You'll see that we have typed in a lot more this time to where all you have to do is find words here and there. So it shouldn't be as intensive on you guys as it has been. So just make sure you're listening, and you can pause me at any time so that you can write stuff down so you can technically go at your own pace. Okay, so let's get started. When we talk about heat and wind, the main thing we talk about as far as the source of what creates wind is convection. Now, convection is defined as the transfer of heat through liquids and gases. Well, our atmosphere is essentially made up of liquids and gases, so convection is what's responsible for heating the atmosphere and the oceans, okay? So from the heat rising and cooling and falling, that whole process is called convection. So think about it when you think of a house. So if you live in a two-story house especially, you'll understand this. During wintertime, it always feels so much warmer on the second floor than it does on the bottom floor, the first floor. And that's because when things are heated, heat rises up until it's cooled, and then it falls down as cool air. So essentially, looking at this picture, you see this little radiator here producing heat. The heat rises because heat expands and goes up, and then as it reaches the top of the room and cools down, it falls down. So that's why during winter, if you have a two-story house, it always feels so much warmer on the top floor than it does on the bottom floor, and that's because of convection. Convection is that movement of heat in the air. Now, whenever you have warm air rising and cold air sinking, it forms this little cycle like this. So if warm air rises and expands, as it goes up in the troposphere, it eventually cools down. So then that air is going to sink down because it becomes heavier. And this whole process is called a convection current. All right. So the warm air expanding or rising, when it does that, where the air once was, it goes up, and that area is now filled with an area of low pressure. Okay. Whenever cold air sinks down, where that cold air once was leaves behind an area of high pressure. So warm air expands and rises, leaves behind low pressure, and cold air sinks down and now has an empty spot above it, and that's an area of high pressure. So warm air rising, cold air sinking, those are our convection currents, and that is what produces wind. So looking at the creation of wind, we have to look at those convection currents and the heating of the land and the water and the atmosphere. And common sense tells you that Earth's surfaces are heated unevenly. Some areas receive more sunlight than others. Some areas can hold heat longer than others. So because these surfaces are heated unevenly, it causes a convection current to form. So on your surfaces that are warmer, the warm air rises up, and then it cools and sinks over top of another surface. So that convection current creates a nice little breeze. As currents are created, those areas of low and high pressure force the wind to blow. So you could essentially say that winds are created due to surfaces being heated unevenly, which makes a convection current, and also because you have differences in air pressure, because those convection currents leave behind areas of high and low pressure, which creates the flow of wind as well. And looking at this picture, it shows you a convection cell or a convection current and how it creates the wind blowing this way. So you see your warm air rising, going up, but we know as we go up in the troposphere, it gets cooler, cooler, cooler. So that warm air cools down, and then it sinks, and it creates a nice little breeze. Now, when we measure wind, we look at two things. We look at the direction it's blowing, and we look at how fast it's blowing. So if we're measuring wind, we're going to be saying, the wind is blowing at 5 miles per hour northeast. So I gave you my speed, which was 5 miles per hour, and I gave you my direction, which was northeast. So we always add those two things when we talk about winds. And to measure wind speed, we use a tool called an anemometer. It has little cusps on it that kind of spin and gather the wind in the little cups, and it spins, and it tells you how fast the wind blows. So when the wind's blowing, it can make the temperature feel much colder than it really is outside, because it creates this increase in cooling. This can be specifically dangerous during the winter, because what this is called is a wind chill. And a wind chill is whenever the air has an increased cooling and the wind makes it even colder than it really is. So looking at this picture here, if this little person standing out here in this beautiful winter wonderland, her body temperature is 98.6, which is the normal average body temperature. No wind is affecting her. She keeps her same body temperature, okay? So under calm conditions, the body radiates heat, creating that layer of warmth between the skin and the snow and the outside. But throw a little wind in there, in the same scenario, then you'll see that her body temperature drops down to 95 degrees, which is when hypothermia begins, because your body temperature drops so much, okay? So the wind is essentially taking the heat away from your body. That is called wind chill. Wind chill is that increased cooling that the wind causes. Now we have two different types of winds that we talk about. We talk about local and global winds. So just think about the meaning of those words. Local. If something is local, that means, they're close by. If you're a local of Clayton, that means you live in Clayton, right? So local is an area that's close by, a small, localized area, right? So local winds are going to be winds that occur over small areas. These are not going to be wind belts that affect North Carolina and California all the way to China. No, that's not local. Local is a small area. So local winds occur over small areas, and examples of that would be a land or a sea breeze. What happens in these instances is one surface is able to heat up quicker than another surface. And because of that uneven heating, we know somewhere warm air is going to rise, cold air is going to sink, and it's going to create a wind or a breeze, right? So the two different types of local winds we'll talk about are sea breezes and land breezes. Picture A here shows you a sea breeze, and it shows that there is air rising up over the land. So you can assume that the land is warmer in this scenario. The land is, the air is going up, it's rising, but as it goes up in the troposphere, it cools down. It sinks over the ocean, and that cold water temperature and the cool air is now making a breeze going in. That's called a sea breeze. It comes from the sea to the land. A land breeze, which you see here happening at nighttime, you see the air rising over top of the water this time. So now our water is the area that has the most heat. So our air is hot, it's rising, it cools, drops down over the land, and now we have a land breeze. Those are local winds. So let's talk about the details of each type of local wind. First is your sea breeze. You've got to know that sea breezes happen during the day. Okay? Sea breezes occur whenever your land is hotter than your water. Think about going to the beach. When you go to the beach, let's say it's 12 o'clock, lunchtime in July, right? You're on the beach, but even though it's so hot outside, there's always such a nice steady breeze blowing and cooling you down, right? That breeze is always coming from the sea onto the land where you are, laying out on the sand, right? So there's always such a nice breeze during the day at the beach because the land is so hot, that air rises and then drops over the cool ocean as it cools down and brings that nice cool breeze from the sea to the land. That's why it's called a sea breeze. So when this happens, it's always during the daytime. Your land is heating up faster than water. It takes water a really long time to heat up. So your land's heating up faster, that air rises up, molecules spread apart, leaving behind that area of low pressure. The wind then cools down, and the cold wind from the sea blows in to the land to take the place of the warmer air. So warm always follows cold. It's kind of like this big circle or cycle. It's actually a convection current, okay? So one thing to note that you really need to remember is that land heats up faster than water, but it can also lose heat quicker than water, which brings us to our land breeze. Land breezes occur at nighttime, and it's during this time that your land loses all that heat that it gained during the day. So even though it was able to heat up a lot quicker than water does, well, guess what? Once the sun goes down and it doesn't have that heat source, it loses its heat very quickly. Water, on the other hand, now absorbs the heat all day long, and water holds on to heat longer. So at nighttime, your water is warmer than your land. So it's at nighttime where your warm air rises up over the ocean this time and sinks over the land. And that cold breeze now is going to go out to sea, from land to sea. So it is a land breeze. If you ever go to the beach and you go out at nighttime on the ocean, you'll notice that if you're walking on the beach in the sand, no longer is the breeze coming from the ocean and pushing your hair back like it does during the daytime. Now, if you're walking on the beach at night, your breeze is now coming from the land pushing out to sea. And so it's actually pushing your hair forward, okay, because of the direction the wind's blowing from. It is like this because of the uneven heating between land and water. At nighttime, your water's warmer, so your cold air is on the land and breezing out. All right, that is called a land breeze. Whenever you have this warm air going up and then it goes up in the troposphere and cools down, as it sinks down, it then creates that convection current to make the wind blow. Okay, whenever that cold air sinks, it leaves behind an area of high pressure above it, and that wind is created. Now, when you have these different pressures, we look at something called a pressure gradient. We know that land can get hotter than water during the daytime. And when it does, that heat rises up and it cools and drops and creates this wind or breeze from the sea to replace that warm air. And that creates a gradient or a pressure gradient because you had high pressure in one spot and then low pressure in one spot, and now they're not getting along, so there's this little gradient or this little barrier, right? So when we look at that, the lower the pressure, the higher the gradient. So the lower the pressure, higher the gradient. Why does this matter, Miss Joseph? Because your wind speed is determined by the gradient that occurs. So if there is a high gradient, you're going to have strong winds. If there is a low gradient, you're going to have weak winds. So it says here with low pressure, there's a high gradient, and high gradient means you're going to have strong winds. So these can be your storms or even hurricanes. So you see here that low pressure is essentially the cause of strong winds. So low pressure systems are always categorized amongst storms. So your hurricanes that form out in the ocean, they form around a low pressure system. Low pressure always means bad weather. So the lower the pressure, the higher the gradient, the stronger the winds, right? These are going to be your severe storms, your hurricanes, stuff like that. And the force that provides the strength to push the wind or for the wind to blow is called the pressure gradient force. Now, we have this specific phrase for why our winds are curved, and it's called the Coriolis effect. The Coriolis effect is defined as the way Earth makes our winds blow curved, so side to side instead of up or down. When wind blows, it doesn't blow from your feet to the top of your head. Instead, it blows side to side. It is like that because of the shape of Earth, which is, sphere, it's round, and it rotates on its axis, right? So this rotation of this sphere is causing our winds to curve just like the shape of Earth, right? So the Coriolis effect causes our winds to blow in a curved manner because it rotates on its axis. Now, something really cool is in the northern hemisphere, up here where we live, we're in the northern hemisphere, our winds, because of the Coriolis effect, end up curving or deflecting to the right. So they kind of curve to the right when they blow. In the southern hemisphere, they curve to the left first and then go right. So for us in the northern hemisphere, it goes right to left. In the southern hemisphere, it goes left first, then right. Okay? And the Coriolis effect is also responsible for that rotation of your hurricanes. So it rotates the hurricanes around. Same concept, okay? Now we've talked about local winds. Let's talk about global winds. Local and global. We said local was a small area, so global has to be a large area. This is an area across the globe. These are winds that affect huge areas, right? So global winds occur over a large area, and there are a couple of major wind belts we're going to talk about. We're going to talk about the polar easterlies, the prevailing westerlies, trade winds, and doldrums. So first are your polar easterlies. You can assume that these are at the poles, right? So at the very top and very bottom of Earth, your north and south poles, right? And these areas are going to be areas of dry, cold wind. We know our poles are cold, so we know these winds are going to be cold winds, and they're very dry winds. And they blow at high pressure areas. They are located at 60 to 90 degrees. So when you're looking at latitude, you're looking 60 to 90 degrees is where you can find your polar easterlies, okay? And the name of the wind is where they blow from. So if it's an easterly, it blows from the east to the west. Next are your prevailing westerlies. Since west is in the name, this wind blows from the west to the east. The prevailing westerlies are winds that can be found between 30 and 60 degrees, north and south. So you can find them right here, 30 to 60, and down here, 30 to 60, right? And it says they blow from west to east, so over here is west. So they blow from the west to the east. Same thing over here, from the west to the east. And this is the specific wind belt that brings us our weather. Okay, this specifically affects us where we are in the United States. The prevailing westerlies are the winds that bring us our weather. Next are the trade winds. Trade winds are easterly winds. They blow from the east to the west, and they're from 0 to 30 degrees, north and south of the equator. And these specific winds were very important back when trading by sailboats and stuff was happening, because the trade winds, the typical trade routes fell between the 0 to 30 degree mark. And you can see here the different types of things that were traded between this 0 to 30 degree area. You see spices and gold and slaves and flour and meat and lumber and cotton, fur, sugar, molasses. All of these different things were traded from all these different parts of the world. And to get from one part to another, in order to trade their goods, they had to use their sails, right? They had to sail from one area to another. And so the main wind belt they used were called the trade winds. Next are the doldrums. Doldrums are areas right at the equator. So this middle line right here is your equator, and doldrums are right on the equator. And they are areas where there's little to no wind. Okay, it's very calm here. You have rising warm air. It's the equator. It's hot. There's very little wind movement here. The way I always tell my kids to remember it is the doldrums are dull. Not much is happening. Okay, so this is your area where there's little to no winds. Next are horse latitudes. Horse latitudes are at a specific latitude north and south, and it's at 30 degrees north and south. So you see here I circled in the picture, horse latitudes are at 30 degrees south and 30 degrees north. This is an area of calm falling air. So the wind's very calm here, and it sinks down. It's called horse latitudes because in the past, when sailors were traveling from one place to another, once they hit the 30 degree mark in their route, you had this falling air and very calm, very little movement. So they'd have to lessen their load on their boats so that they could get to moving. And most of the people, if they brought transportation like horses, they would throw their horses overboard at 30 degrees north and south to lighten their load so that the wind could be strong enough to push them and continue on their route. Really sad, I know. All right, I know you guys have heard of the jet stream before. There are actually multiple jet streams. The jet stream is a wind belt that travels from west to east So it blows from the left to the right, and it's found at 10 kilometers up in the troposphere. So it's this narrow band of really strong winds at the top of the troposphere. You can have a subtropical jet stream, which is going to be one that's carrying warmer temperatures and warmer air. And then there's also a polar jet stream, which is more so by your poles, and this carries cooler air. On your notes, it has you labeling the global winds. So you need to make sure from 60 to 90 you have easterlies. From 30 to 60 you have westerlies. On this 30-degree line is horse latitudes. In between 0 and 30 on both sides is your trade winds. And in the middle where the equator is, those are your doldrums. Down here on the southern hemisphere, when you hit 30 degrees, those are your horse latitudes again. 30 to 60 degrees south is your westerlies again, and 60 to 90 will be your easterlies again. So pause this slide and make sure you fill in the words that are in white and black on this globe. Now, that is it for the notes today. If you have any issues, any questions, you don't understand something, reach out to us. We will be more than happy to help. And I hope you guys have a great day.